Hi, welcome to Shiko Math Lab Fun Probability Problem Solving sections here. And after you watch the video, if you like the video, and please subscribe the channel. Or if you have a better way to solve this problem, please feel free to leave me a message. Or if you have any other problem you want me to take a look, please feel free to leave a message as well. I don't guarantee I know how to solve every problem, but at least I can take a look and give a try. Okay, so today for this section, we're going to take a look at Pareto random variable distributions here. So we're going to take a look at some very basic things about the Pareto distribution. So for here, we said that X is a Pareto distribution with a probability density functions, like what we described here. Then the first thing is here, we want to verify the f of X is a valid PDF. Now we want to find what value, the expected value going to exist, and what is the value of the alpha, the case moment of the random variables exist. Then we're going to take a look if I give alpha a specific number is 3, then what is the variance of X? So those are the very, very basic kind of probability problem. So let's take a look here. Okay, so let's go to the whiteboard and let's take a look at that. Let's start to solving the problems here. Okay, so we have said f of x is here, right? So from the problem we said f of x, this is the Pareto. So this will be equal to the alpha, and this is 2 to the alpha, and x the alpha plus 1. And x here is greater than equal to 2, and alpha is greater than 0 here. So the first thing is here, the reason why this is greater than equal to 2 is because this one here really is the you can change is change the values to like different numbers here. Okay, so in fact the alphas, these numbers here, this is like we mentioned, it can have different values. So this is basic, it's a scale parameter for the Paretos here. That's why here we said x is greater than 2 here. Okay, so the first things here we said, hey, let's verify is this a valid PDF here. So the part A is here for the verify is a valid PDF. That is a pretty easy here. That means if it's a valid PDF, because this is a continuous random variable, that means when we integrate the whole range, the whole domains here, so it's from 2 to infinities here, right? Now if we integrate this density functions, so what are we supposed to get here? We hope that this will reach what? Will be once, right? So that's why we want to see, is this become once here, all right? So now this ones here will just be, we take the typical integrations here is like what we learn in the calculus. So this is alpha, 2 alpha. Then here you can say there is x to the alpha plus 1 dx here, right? And then you can just use the power rule. So now I have it here, this is alpha, 2 alpha. This is just a constant. So this is my n, so it's negative alpha plus negative 1, so it's times, really it's negative alpha minus 1 plus 1. Then this is negative alpha minus 1 plus 1, right? So it's n plus 1 over n plus 1s here. Okay, so now let's, then your limit is the infinity to 2s here. Okay, so let's continue. So this is alpha, 2 alphas here, right? So this ones here will just be negative alphas, right? And then here, this will be the negative alpha. Okay, so then you have the 2 to infinity. So in here, the negative alpha, because alpha is greater than 0, so this one you can really kind of change to here. So this is negative alpha, so that be, okay, so let's see here, this is negative alpha, then this is, you can move this x alpha to here, to infinity to 2. So this is alpha to alpha. So when I put the infinities here, the upper bound here is infinity to here, because the x, the alpha, so alpha is greater than 0, right? So the denominator will approach to the infinity, and then minus, you put the lower values here, and also the reason why this will approach to infinity, because also x is greater than 1. In here, the x is greater than or equal to 2, right? So that's why this part are going to be approach to 0. Then you minus, you put the lower bound. The minus here got a, take a look here. Here got a negative sign. So minus become what? Become positive, right? So it will become positive. You put a 2. So this is 2 alphas here. That's why you will become 1s here. Okay, so that's why I know the f of x here is a PDF. Okay, so be very careful here, right? So the here is use your calculus knowledge. Why this one will approach to 0? Because x is greater than 1 and alpha is a positive value. So that's why the denominator getting bigger and bigger here. Okay, so now let's take a look at the second part. They want to find the expected value of this Pareto. So the expected value of this Pareto will just be the 2 to the infinity. Then you have x and you have alpha, the 2 alpha, and the x, the alpha plus 1 dx here, right? Okay, so we still can move the alpha and the 2 alpha to the front, and then here x and x alpha, so become what? X alpha, correct? And the dx, and from the 2 to infinity. So now in here, this is alpha, 2 alpha. So this one's here, if you want, let me try to write it. So this is 2 infinity. You can say it's x to the negative alpha dx, right? So then use the powers rule again. So what is it here is negative alpha plus 1. Then the x, the negative alpha plus 1 here. Okay, so now you have 2 to the infinity. So let's see here. So it's alpha, 2 alpha. Then let's put this number. So this is 1 minus alpha on the bottom here. Then here, you put it in the bottoms here. This will be alpha minus 1, right? So this will be alpha minus 1 to here. Now here is infinity to 0. Okay, so now let's take a look again. So when you put the infinity to x here, so x is greater than 2, so that's fine. But in order to, to let this things approach to zeros here, right? So what I have to have the alphas here. So that means alpha has to be positive, right? So that means alpha minus not alpha, I mean that the exponents have to be positive. So that means alpha minus 1 has to be what? Has to be greater than what? Greater than 0. Right? So it has to be greater than 0. And then that's why what happened here, the alpha has to be greater than 1 here, right? And then that's why this terms here. So what happens here? So that means these terms here will approach to what? Will approach to zeros, right? Okay. So also you might ask why is alpha greater than 1? And why is alpha cannot equal to 1 cannot be greater than equal to once, right? Greater than equal to 0. The reason why it cannot be equal to 0 is because if you equal to 0, this term will become 0, right? So it's non-defined. So that means alpha has to be greater than 1. So after that, if alpha has to be greater than 1, then when you put this value there, so infinity will be 0. So it will be 0 minus what here? You put a 2 in here, right? So it will be the, oh, okay, so I'm kind of, okay, so this one's here will be the 2's here, right? So here, this is 1 minus alpha, okay? So when you put a 2 here, what do you have here? 2 to the what? Alpha minus 1 here, okay? So now this is the, so like see here, let's simplify this a little bit. So it's a 2 to the alpha. So here I have minus, right? So let's see here. So this is in 0 minus, you put the 2. So this is a minus, and then this is 1 minus alpha. And I can put this is 2 alpha times 2 to the negative 1. Correct? Okay, then I will be able to cancel this alpha, cancel this 2 alphas here. Then this 2 to the negative 1, you can flip it and will become 2 here. So the answer here, it will be the what? It will be the 2 alpha 1 minus alpha, and so that will be the, oh, wow, so I forgot here, got the one, don't forget this negative, it's right, negative 2 alpha 1 minus alpha, or you can change this will be the 2 alpha, then just switch the button, this is alpha minus 1 here. All right, so this is the means here, and be very careful. In order for this mean to be true here, so we have to have what? Alpha has to greater than 1. This is the condition for this means here. Okay, so now let's do the same thing for the, for the case moments here. So let's see, take a look. This is expected value, x to the k. So we do the same thing. So we do the 2 to the infinity, x to the k. Then here, this is x to the alpha plus 1. Then the alpha 2 to the alpha dx here. Okay, so this one's here, we can change to the 2 to the infinity. So now let's move the alpha and the 2 alpha to the front here, all right? So this is alpha, 2 alpha to the front. And so what here, I have x to the k minus alpha minus 1, right? Then the dx here. So now let's do the same thing. Use the power rule. So this will be k minus alpha. Then this is x here, k minus alpha. Okay. Then the same things here, you can be from the 2 to infinity. Or if you want, I can put this one at the bottom. This is k minus alpha. All right, then this will be x to the alpha minus k. Then from the infinity to 2. Okay, so we do the same considerations here. All right, so if you let the x become to, if the x is going to the infinities here, right? So if x is go to the infinity, that means here is going to be the infinity. So in order for this one to approach to 0, because so what is the alpha minus k has to be? Alpha minus k has to be greater than 0, right? Because the greater than 0, then x is great, approach to infinity. So the power will be positive, so it's going to the 0. So denominator will become very, very large. So that's why I will have alpha greater than k. So for the case moments here, so that's why you need to be careful. Your parameters here, the alpha has to be greater than case here, right? So now we can do the same things here. You plug in here, right? Okay, so this is the alpha, the 2 alpha, and then you put in here will be 0 minus, right? Minus you put the 2, so this is k minus alpha, and the 2 to the what? Alpha minus k. See here. Okay, so just like we did for the previous one, we can take a look. So this is -1, k minus alpha, then the 2 to the alpha, 2 to the negative k, right? And then we will just cancel alpha. All right, so that's why we will have this is negative alpha, then this is k minus alpha, and then this one will be 2 to the k's powers, right? So if you want to, you don't want this negative signs here, then you can have in here, so you can have here, so you can alpha the 2k, then this is alpha minus what? Minus k's here, right? So this will be the case moments here, right? So this is the case moment, and what is your requirements here? The alpha has to be greater than what? Alpha has to be greater than case here. All right, and so let's take a look the last part here. So the last part is they want to find the variance of this Pareto and the variable. So the variance here, we know the variance of the x is equal to the ex square minus the ex the whole thing squares, right? So now because this is the second moment, so alpha has to be greater than 2. So in here they say, hey, let's set the alpha equal to 3. So it's okay. So it's satisfy our definitions, right? So now let's see here the expected value of x equal to 2, right? So we said from the previous one, we said x equal to 2, right? So k equal to 2, alpha equal to 3. I can substitute to the previous formula. So alpha is equal to 3 minus 2. Then here this is 3, right? Then is 2 to the what? 2 to the how many powers here? The 2 to the second powers, right? So this will be what? So this will be 12, right? Okay, so this will be 12. And then also we can put this one, the expected of the value x from our part B. So it will be 2 alpha, so it's 2 times what? 2 times 3. Then what is that? Alpha minus 1. So it's alpha minus 1 is 3 minus 1. So what is here is 3, right? Okay, so now this one is very easy now. So variance of x will just be the 12 minus 9. So it's 3. So that's it. Okay, so we have the good, I think after this problem, got a good ideas about what is the Pareto distributions here. Like if you like the way I solve it, and please subscribe the channel, or if you have a better way to solve it, I would love to see it. So leave me a message about it. All right, so nice to talk to you, and cannot wait to show you next problem I'm going to solve here. Have a good day. Okay, bye bye.